Right, so this is question 5 part B. Now this is all dependent on part A for us here, right? So that's our function. Now but say if you had if your function was even, there's a couple of shortcuts to bear in mind. I think our function here is neither odd nor even, but if your function was even, you'd only have to work out if it was even, I'd mark that as E. You'd have to mark out this, you'd have to figure out that one and that one if you had an even function, and this one becomes 0, so you wouldn't have to bother even working it out. So even means it'd be symmetrical about the y-axis. So for example, if your function looked something like this, that would be symmetrical about the y-axis. So you'd only have to work out a0 and an, and the opposite is also true. If the function was odd, so the function would be symmetrical about the origin, so that'd be a classic one there. That's x equals y. That function there would be odd because it's symmetrical through the origin. In that case, you'd only have to work out bn. You'd only be working out bn in that case, and then you'd be scrapping the other two. But again, say if you had an even function, you'd only be working out a0 and an. But now in our case here, this is neither odd nor even, so we're going to have to examine the 3 different coefficients. So first of all, we're going to get coefficient a0 here. So for us, that we can write that a0 equals 2 over 2, because for us, remember in the first part of the question, the period was 2, and this integral here, 2 over 2, is just going to become 1, and downstairs here, minus 2, that's going to be minus 2 over 2, so it's going to be minus 1. And f of t, what was our function? Our function was, f of t in the first question was, our first part was t minus 1. So instead of f of t, we're going to have t minus 1 there, and we have an old dt, right? So 2 over 2 becomes 1, that disappears, and we're left with 1 and minus 1 here. And then, we can have t dt, we can separate them out then, and we have 1 dt here. And that becomes, integrating this guy, we get t squared over 2. We're going to still have to apply our limits, 1 minus 1 minus the second integral, then integrate that, you're just going to get t, and we're going to apply the limits 1 and minus 1 there. So that gives us, in the first guy there, we're going to have t is 1, so we have 1 squared over 2 minus 1 squared over 2, and then with this minus here, and we're going to have 1 minus 1. Be careful with that. So that becomes a half minus a half, because minus 1 squared is just 1, so they'll cancel each other out. Minus, and 1 minus minus, that's going to be 1 plus 1. So these two cancel each other out, and we're left with minus 2. So we've worked out our first coefficient, a0 equals minus 2. Now we're going to look at our second coefficient, an there, a sub n. And now for us, the big T is 2, so that's going to be 2 over 2. And 2 over 2 there gives us 1, and we get minus 1 down here. F of t is t minus 1 times the cosine of 2n pi over t, or times small t over big T, which is 2 dt. Now, these 2's will cancel out. So these 2's cancel here, so we're going to be left with integral from minus 1 to 1 of t minus 1 times cosine n pi t dt. And again, we can separate them out into two pieces. So we can distribute this. We can have t times the cos and minus 1 times the cos. So we end up with this guy here, t times cosine n pi t. And then we have minus 1 times, so minus, there should be a dt in there. We have a minus 1 down there, and that's going to be cosine n pi t dt. Now there's some shortcuts we can take here. You see this first guy, t, right? This is a function, t by itself. So, we can say that f of t equals t. And that will give us a graph something like this. 1, 2, 3. When t is 1, f of t is 1. When t is 2, f of t is 2. When t is minus 1, f of t is minus 1. Do you see that? It's a line straight through the origin. So the function t is odd. Now, so this function here, this is odd. And this function here, cos of nt, cos of anything, what does a cos look like? I have it up here in my browser here beside me. So the cos function, you sketch the cos function. It starts here, goes down and up, and starts again. So it's symmetric. You see that the cos function is symmetric about the y-axis. So the cos function is even, right? And the rule is the product of an odd and even function. So if you have an odd and even function multiplied by each other, odd times even will always give you an odd function. And we know that the integral, this is a shortcut now for this stuff, the integral of an odd function, the integral of an odd function, as long as the limits are okay, they're symmetric limits, the integral of an odd function always equals 0. So we can get this whole guy here and not go any further. With this knowledge we can turn him into a 0. So that makes life easier. So we can rewrite our integral now as 0 minus this integral minus 1 to plus 1 of cos of n pi t dt. Now what are we going to do with this guy? Well, we're going to integrate this fella. So we have our minus outside here, and cos, what does cos integrate to? Looking at my logbook here, cos goes to positive sine x. So this is x in here. So we get sine n pi t inside the brackets multiplied by 1 over the first derivative of the contents of the brackets with respect to t. So that's going to be like a constant times t. So we're just left with n pi down here. And we still have to apply our limits. So that tidies up like this. We'll have minus 1 over n pi in front times sine n pi t. We don't really need that bracket there, but sure, we can stick it in anyway. So I can bring in brackets here because I still haven't applied my limits. So we're holding out this minus 1 over n pi, and now we're going to apply our limits. So we're going to have sine n pi, instead of t I bang in the 1, so it just leaves us with sine n pi minus sine n pi, and instead of t we have a minus 1 in here. So that's like minus 1 over n pi, and we have sine n pi minus sine of minus n pi. Now if you look up page 13 in the log tables, there's a little rule up near the right hand corner that tells us that sine of minus something equals this. You get this, where a can be anything, right? So sine of minus a equals sine a. So this guy here, we can turn him into a positive. So if he goes positive, that minus the same thing there gives us a 0. So we end up with 0 there. So what's that we've worked out? That was AN, wasn't it? Yeah, so we've worked out that AN equals 0.